Okay, so for my project, I did question number 4, which says a football is thrown from the ground with an initial velocity of 15 meters per second at an angle of 35 degrees. What is the max height the football attains, and how far does the football travel? So first, I'm going to draw a chart or a picture of what the football will actually look like. So here's the 35 degrees, the delta D, Y max, and the delta dx max. And then the initial velocity, which is 15 meters per second. Okay. And then from there, it's easiest to draw a right triangle, which will show, which then you can find the different sides, which is helpful in the finding the delta dy and x max. So this is 35 degrees, and then this is 15, and the v, the velocity x, and then the velocity y, and then velocity x. This is the opposite, adjacent, and hypotenuse. Okay, so then to solve for the different sides, you do cosine 35, which is the angle, and then the vi, the initial velocity of x, over 15, which is your hypotenuse. And then to get the initial velocity of y, you have to do sine 35 equals the initial velocity y over 15. And then you multiply, so it's 15 cosine 35 equals VIX, and then sine, or 15 sine 35 equals VIY. Okay, and then get out your calculator and you do it out. So 15 cosine 35, which equals 12.28, and then 15 sine 35, which equals y equals 8.6 meters per second. Okay, and then to solve for what the question is asking for, you have to do the at ty max, so make two different charts of it, which is easiest to solve for everything. So x, y, vi, vf, a, t, and delta d. And then you do the same thing for the x max. So x, y, vi, vf, a, t, and then delta d. Okay, so we're going to start with the y max. So you just plug in the said numbers from above, so 12.28 and 8.6 meters per second, and then 0 because it hits the ground. And then the acceleration is always 9 for the y side, it's always negative 9.8 meters per second squared, and then 0 for the x max. And then you do not know the time and the delta d, so to solve for the delta d, we have to use equation 4, which is vf squared equals vi squared, plus 2ad, because we are not given the time. And then so you just plug in the numbers, so 0 squared equals 8.6 squared plus 2 times negative 9.8 d. And then you just solve, so 73.96 plus negative 19.6 d equals 0. Oh, we're running out of room. And then, well, you subtract the 73, so it's negative 73.96 equals negative 19.6D. And then for D, because you divide, you get that D equals 3.78 meters, which is the max height of the football. Okay. And so now we're going to do the same thing on the other side for the X max. So you plug in the same numbers, 12.28 and 8.6 meters per second. And then same thing, 0. And then negative 9.8 meters per second squared. And then the displacement, or the delta D for y is 0. Okay. And so now we have to solve for the x side, which you use equation 3 for, which says delta D equals VIT plus 1/2 AT squared. Okay. So you just plug in the numbers. 6t plus 1/2 negative 9.8 t squared. So 8.6t minus 4.9 t squared equals 0. So you subtract the 8.6, so you get negative 8.6t equals negative 4.9t squared. And then you take away a t, so you have 1t left. Then you divide by negative 4.9, in which you get that t equals 1.7 seconds. So you fill that in your chart, 1.75, excuse me. And then now we have enough information to solve for the last part, which says how far does the football travel. So we're going to flip it over, and so there's no acceleration, so we're going to use delta D equals VT. So delta D equals 12.28 times the time, which we just got, 1.75, and then use your calculator, and we're going to get 12.28 times 1.75, which you get 21.5, in which is how meters, which is how far the football travels. Well, there it is.